Hi, good afternoon. This is Ernesto Burden. I'm the publisher of Military and Aerospace Electronics, and I'm here with our editor-in-chief, John Keller, a face that many of you know, and a mustache that many of you know. We're here by way of Google Hangouts in Google+, and we're just having a brief chat to bring you up to date on the most important news stories of the week in military and aerospace electronics from the website, and John is here to offer some of his opinions on them. And we're going to start with what John's identified as probably one of the most timely and important pieces that has come out this week, and that is a blog post by him that's tackling the international suspicions of U.S. encryption technology that are growing and how they're putting defense companies in a bind. And this, of course, ties in directly to the news that the U.S. has made in general relating to spying issues. So, John, what's your take on this?
Well, what I'm really concerned about is we've got a defense industry that's already under tremendous pressure. We've got sequestration, we've got dwindling defense budgets. We've basically got an environment out there that's hostile to the military and the military doing business. But that's not new. What's interesting is with the military these days, with COTS technology, there isn't a whole lot of cutting-edge technology anymore that really differentiate military contractors from commercial companies. One of the things that really does differentiate, however, is military encryption technology, information security technology, and also cryptography. These are really areas where the U.S. defense industry has been on the forefront. But and also it's a big opportunity potentially for U.S. military contractors to export this kind of technology to friendly militaries around the world. But what we've got now is we've got the pretty well ongoing NSA scandals of spying not only on U.S. citizens at home, but reports of the NSA spying on international leaders, on cell phones and things like that. What this has created is a very serious breach in trust of internationally, and so what I understand people are concerned about overseas is that there's concern that the NSA perhaps is building backdoor software into some of these encryption systems that might enable them to spy even more. So what's happening is internationally, other governments, foreign militaries are starting to sour on U.S. encryption technology, which could really put a crimp in an already beleaguered U.S. defense industry. So,
now, you said in your post that it doesn't matter whether the NSA is actually doing that or not. It matters what the perception is.
Well,
what can they do? What's the next step that the NSA or the defense industry can do to change that perception?
It's an interesting question because at this stage of the game, I don't know if that perception can be changed, at least not immediately. There's been very serious damage done to the reputation of U.S. encryption technology all over the world. Can that be rectified, repaired overnight? Certainly not. Now, can it be repaired at all? I think that's an open question. But like I said, it doesn't matter. Is the NSA actually doing it? We'll probably never really know. But the perception is out there, and the international community is looking elsewhere now for this kind of technology. Now, does this have the potential to spawn a cottage industry overseas of very smart people creating their own encryption algorithms? I think that is a very real possibility. What's actually going to happen in the long run, I don't know. But I think that the defense industry, not because of what they themselves have done, but because of what a branch of the government has done, are really in trouble now. And what can they do? I'm not even quite sure.
Do you see any? I mean, you've said you're not sure what they could do, but you see any possible bright spots? I mean, are there places that you said that this could spawn an interesting cottage industry overseas? What could people do here to begin to, I guess, to begin to reassure people about the security, or the more, not so much the breaches in security, but the breaches in faith, I guess?
Well, the breaches in trust, and I can't emphasize the deep damage enough, because the way it works is encryption type of algorithms and cryptography and the types of things that are going to ensure information security, these algorithms, these approaches, all of these have to be certified by the National Security Agency, and it is the NSA that is not trusted now. So we have a situation where you have an NSA, which has a very compromised reputation all around the world, as well as at home, but the NSA has to certify encryption or it can't be used. So it's a very difficult problem right now.
Boy, would not want to be working in public relations for the NSA right now.
Well, you know, the NSA, I don't think they really care too much about about public relations. I remember a time years ago where I found a phone number to the National Security Agency. I was trying to put together a story. I called the number and I identified myself as a reporter. And the only thing they said before they hang up was, "How did you get this number?" So I don't think the public relations people at the NSA particularly care.
Well, John, they may have this footage now stored away for future reference, though. So maybe you'll get a call back.
Probably not.
So the next story that you'd identified was BAE Systems is joining forces with Boeing in a DARPA program to advance electronics thermal management. So what's the scoop with that?
Well, it's interesting. DARPA has a program called the iSchool program, and what it is it is an attempt to build liquid cooling right into processors, digital signal processors, FPGAs, ASICs, anything that generates a lot of heat. And you know, high performance embedded computing, by its very nature, really does generate a lot of heat because it's crunching so much data. Thermal management is a huge problem. It's a problem that has the potential and the threat to stop Moore's laws in its tracks. So what DARPA is trying to do is develop at the chip level, to be done at the fab, to be designing in liquid cooling into these chips. They've had an RFP on the street for quite a while. IBM was involved in some early development, but we just had a couple of contract awards this week to BAE Systems and Boeing, two very big defense contractors who have a big interest in thermal management for all kinds of digital signal processing applications. So it'll be interesting to see where that actually goes. Their current research, it's going to last for months and years. Not a lot of years, I think a couple of years at least. But it'll be interesting to see, you know, where this actually goes. It will be a challenge, however, to switch DARPA developed technology into the marketplace. Sometimes it can work, sometimes it doesn't, and you have to keep in mind that what DARPA is really all about is a proof of concept, just to see if these types of things are possible. DARPA is not so much concerned, and really shouldn't be, with how marketable it can be, how manufacturable it can be. So
well, what's the big win if it works, though? I mean, what are the major paradigm shifts that happen if they figure it out?
Well, the paradigm shifts here are, right now, it can be very large and heavy and clunky to designing cooling for high-performance embedded computing. You need to use either a series of fans or large heavy heat sinks, or sometimes you have physical pipes and hoses going over boards and under boards and things like that to draw the heat away from sensitive electronics, so these these processors can function,
Right.
at their highest level. So what this could do is it's got the potential to move heat away without the use of fans, heat pipes, heat sinks, things like that. So as far as a size and weight prospect, it's really got a lot of potential.
Well, it would seem that down the road it would have to have market potential then, just as a result of that.
Well, the market potential is something that's going to come later. Right now, DARPA and Boeing and BAE Systems are just going to try to see if they can actually do it. Will this kind of technology or part of it eventually make it into the commercial marketplace? I think possibly so, but it's not going to be something that we're going to see in the next year or two. It probably could be 5 years or 10 years down the line.
Oh, well, heaven willing, we're still sitting here to see it. GDC4 Systems to prepare WinT Increment 3 for deployment in $475 million contract. That's the last story that we're going to touch on today. And this is a very new one. You just covered this 2 days ago?
I think so. Well, what's happening is, the real story here is the Warfighter Information Network-Tactical, or the WinT program. General Dynamics C4 Systems out in Arizona has been working on this for quite a while. The big thing, though, is with this contract that this is moving it much closer to deployment. This is for an engineering and manufacturing development, which is Pentagon speak for simply full-scale development, deployable technology. In other words, what the WinT technology really promises is to bring, internet-like information sharing, communications to soldiers at the leading edge of the battlefield, where, until very recently, the only electronic communications they've really had is voice radio. And military people have told me time and again that when the shooting starts on the battlefield, you can neither hear and you cannot scream loud enough to be heard. So really, when you look at communications that's limited to voice communications, it's all but useless. But with WinT, you couple that with wearable computers and all kinds of displays and things. You can graphically present to warfighters where the friendlies are, where the enemies are, what are some logical avenues of advance or retreat. You can exchange text messages. It's really a much more efficient way to communicate, and really, in a lot of ways, can enable communications at a critical time that voice alone just can't handle.
Well, this is interesting timing for this, though, isn't it? With the with the withdrawal of ground forces from battlefields, we're at a time when there, at least it seems like there's a de-emphasis on what's happening on the front lines. What's your thought on the timing here?
Well, the timing is interesting, but what I really think about a WinT type technology, we are possibly, and this is just my opinion, but we're possibly at the precipice of a new era where the big iron type of large-scale land warfare really might be a thing that's becoming a thing of the past. There's a new emphasis on special forces, small forces, things like that that are very agile, very fast. You can get them in and out quickly. But although the WinT program is designed initially for large-scale forces, I think there's going to be a lot of technology there that can be adapted and changed and customized for some of the small unit warfare that I think we're going to be seeing, much more the rule rather than the exception in the future.
Well, that's interesting, and that potentially then maybe also opportunities for those small units to better undertake electronic warfare.
Well, I think so too. And really, what we're seeing is we're seeing a de-emphasis or a lessening of emphasis on large unit type military tactics, and we're seeing a big emphasis now on small unit special forces tactics. We've seen solicitations come out recently for a special forces type of battle suit that has embedded computing and cooling and ballistic shielding and things like that. And for this type of new warfare, I think that it's really going to it really will adapt itself for this new type of warfare that we're going to be seeing.
It's going to be amazing to see how this plays out in the next couple of years. Well, thank you, John. We are at the end of our time and at the end of our stories, and thank you for those watching and for those who didn't get a chance to see it and who may be watching in the future. This is Ernesto Burden with Military and Aerospace Electronics. That was John Keller, Chief Editor of Military and Aerospace Electronics. You can find us at militaryaerospace.com. For all the latest in aerospace and defense electronics news, and we will talk to you soon.